Good morning, students. Today we are going to find the area of segment. Okay, so area of segment. So first of all, we will try to know what is the segment. Okay, so segment, as you all know, segment is the region enclosed between the chord of the circle and the chord of the circle and what we can say this arc. Okay, so which arc? Suppose AB is arc here and this chord is chord AB. So we'll try to find the area enclosed between the chord AB and the arc AB. So this is the area, isn't it? So this area, this shaded region, we are going to find. Okay, so this is, let me use another color pencil to mark the chord. Okay, so this is the region, the shaded region we are going to find. So let's assume the center of the circle as O. Okay, so this is the center of the circle and I am going to join the center of the circle and the point A. Okay, so when we will join, of course we will get the radius of the circle, isn't it? So this is the radius of the circle. So let's assume the the radius of the circle as R. Okay, and circle with center O. So what we can name this circle as circle with center O and radius R, isn't it? So we can name like that. So let angle made by the arc AB at the center of the circle is theta degree. So this is theta. Suppose this is theta degree. So angle AOB is equal to theta degree. Okay, so we are going to derive the formula to find the area of the segment. Okay, so how we can find? So what we are going to do is that, so area of segment, so this segment, what we are going to find, first we will find the area of this sector. Which sector? This one sector. So area of sector, okay, and if you subtract this area of this triangle, if you subtract this yellowish region, okay, from the whole region, the whole sector, you will get the blackish region, area of that segment. So the area of segment, so what we're going to do, we'll just subtract area of that triangle, okay, from area of sector. So as you know how to find the area of sector, so how you can find area of sector? How you can find area of sector? You know the formula na, theta by 360 into 360 into pi r square, some square unit, isn't it? So this is the area of sector. Okay, so now we are going to find area of triangle. Okay, area of triangle. So what we know, the basic formula, 1 by 2 into base into what we know, height na. So what we are going to do is, we are going to draw one altitude of triangle AOB. So AOB, so what is altitude, you know now? So we'll try to draw one perpendicular from the O to chord AB, isn't it? So this is a perpendicular from the O is the center of the circle, to the AB. So let's mark this point as some point D. Okay, so this is a D point. Okay, this is the D. Okay, so OD is the altitude. So we don't know what is the OD. So we'll try to find OD. So first of all, you can see triangle AOD. You can see na, triangle AOD. So triangle AOD, see triangle AOD. What is triangle AOD? So triangle AOD and triangle, this triangle we are getting na, BOD. So triangle BOD, what we have. So let's try to prove these two triangles as congruent. So shall we write AD is equal to BD? We can write or not? As you know, in earlier classes you might have studied, if you draw a line from the center of the circle to the chord, and if that line is perpendicular to the chord, if that line is perpendicular to the chord, if that line OD is perpendicular to the chord, then it will bisect the chord. In class 9th you might have studied. So OD is a line that is passing from the center of the circle, and it is also perpendicular to the chord AB. So of course it will bisect the chord AB, isn't it? So this is the theorem you might have studied in class 9th. So what, again I am repeating it. So when you draw a line passing through the center of the circle, and if that line is perpendicular to the chord, that line will bisect the chord. So from that only I have written AD is equal to BD. Okay, now the second one, shall we write OA is equal to OB? OA is equal to AB, we can write now. OA is equal to AB, OB. OA is equal to OB, shall we write? Because they are the radius of the circle, isn't it? They are the radius. And shall we write OD is common? OD is common in both triangle. So OD is equal to OD, they are common, isn't it? So they are common. So we can say triangle, these two triangles are congruent na. Triangle AOD, triangle AOD is congruent to triangle BOD. They are congruent, isn't it? So if they are congruent, their corresponding parts like corresponding angles and corresponding side will be equal. So this angle, let me mark this by another color. So this angle, which angle? Angle AOD, this one will be equal to angle BOD, isn't it? So we can write angle AOD will be equal to angle AOD will be equal to angle BOD, isn't it? You can write CPCT. Okay, as we know, these two angles are equal and the whole angle is theta. Angle AOB is theta, isn't it? No? They are theta degree. Theta we have represented by theta na. So angle AOD will be equal to the, so AOD will be equal to the half of theta. Also BOD also equal to half of theta, isn't it? So now, so AOD and BOD is equal to half of theta. So these two angles are theta by 2. So these two angles are theta by 2 and this also are theta by 2, isn't it? So let's use some trigonometric function there, trigonometric ratios there. Okay, so as you know, sine theta and cos theta. Okay, sine theta and cos theta. No, you know sine theta. So what we have sine theta as? Sine theta is equal to perpendicular by hypotenuse na. So what is perpendicular here? So the angle we are taking as sine theta by 2 na. So in front of that sine theta by 2, AD is there na. So we can say the AD is the perpendicular here. Okay, so AD is perpendicular here na. We are taking sine theta by 2, sine theta by 2. So AD is perpendicular here na. So AD and hypotenuse is here. OA is the hypotenuse or not, isn't it? OA is the hypotenuse. Let's see again where it is. Okay, OA is the hypotenuse here, OA. Okay, so now OA is the hypotenuse. Okay, so we are going to find AD here na. So AD is equal to what we can write? AD is equal to OA into sine theta by 2. So what is OA? OA is the radius of the circle na? R. So R sine theta by 2 is equal to AD, and we know that twice the AD is equal to the, shall we write 2R sine theta by 2, isn't it? And you know that AD and BD are equal. Okay, so twice AD here, twice AD AD का दो गुना क्या हो जाएगा? AB हो जाएगा कि नहीं? क्योंकि AD और BD क्या है? They are equal. So shall we write, instead of 2AD, shall we write AB? So AB is equal to what we'll have? 2R sine theta by 2. Okay, so shall we, so I'm going to round it. Okay, we will use this. Okay, a, so we will mark it as equation a 1. Okay, so now we are going to use a cos function, cos ratio. So you know that cos theta by 2 is equal to what? Base by hypotenuse. So what is base here? So base is o, od is the base, and what is hypotenuse? Oa is the hypotenuse here. Okay, you can visit again and see na here. What is base here? Base is oa na, od na, sorry, base is od here, and what is hypotenuse? Oa is the hypotenuse, so I have kept like that only. So oa, so what is od? We don't know od. Okay, what is oa? Oa is the radius of the circle, so we can write it as r. And what is cos theta by 2? Cos theta by 2 is cos theta by 2. Okay, so we will find od here. So od will be equal to the r cos theta by 2. Okay, so I am writing it. Okay, so let's assume it is a equation 2. Okay, so now in the beginning what we have written, we have written the area of the triangle as base into height. So in this triangle, what is base here? So base is AB, isn't it? AB is the base, है ना? AB is a base, and OD is the height, na? So shall we write this formula as 1 by 2 into base into height, isn't it? 1 by 2 into base into height, area of triangle. So area of triangle, shall we write area of triangle AOB is equal to 1 by 2 into base into height. So what is base here? What I told, base is AB, and what is height? Height is OD. Okay, some square unit. Okay, so is equal to, what is AB? We have calculated AB as, so let's see what we have calculated. AB is equal to 2r sine theta by 2 here na. So shall we put this 2r sine theta by 2? What is OD here? OD we have calculated. OD is equal to, OD we have calculated r cos theta by 2, isn't it? R cos theta by 2. Okay, so let's simplify this. So this 2 will cancel out na, and r into r square, this r na, we have this r and this r na, so r into r square, and sine theta by 2 and cos theta by 2 na. So we have the formula area of triangle as triangle AOB as r square sine theta by 2 and cos theta by 2. Okay, so what we have assumed, the angle made by the arc at the center of the circle is theta by 2. So what we got as the area of triangle, angle made by the arc at the center of the circle is theta. So what we got the area of the triangle as, we got area of triangle as r square sine theta by 2 and cos theta by 2. Okay, so now we are going to put this formula in the area of segment. So what we have written earlier, we have written area of segment is equal to, what we have written, area of sector minus area of triangle na. So what is area of sector? So we know na, theta by 360 na into pi r square minus what we have calculated, area of triangle. Area of triangle we have calculated r square sine theta by 2 and cos theta by 2, isn't it? So this is the formula of area of segment. Some square unit you can write. Okay, so some square unit. So as you know, the area is also in some square unit na. So again you can simplify this formula, but this is the okay one. Okay, so you can if you want to simplify the formula, you can take r square as common. Okay, r square is common, so you can write here theta by 360 into pi something minus sin theta by 2 and cos theta by 2. But I think this formula is easy to remember: theta by 360 into pi r square minus r square sin theta by 2 and cos theta by 2. So whatever question will come, if the angle made by the arc at the center of the circle is theta, so what you have assumed, we will do use this formula: theta by 360 into pi r square minus r square sin theta by 2 and cos theta by 2. Okay, thank you.